Okay, so milestone one, we're required to having a composite pattern right now for our aliens, because we are trying to make an alien grid and an alien column, which will be used for our collision system uh, in the future. And so right here, as you can see, we have our composite pattern, leaf, composite, and component. So in the game, we can now create the alien grid, and as well as the alien column is right here. So once the aliens is being created, we can add this layer of pattern, to have the column to have each column has two I believe two rows of crab, two rows of octopus, and one row of squid, right? The next thing we did is movement. So basically, we created our movement commanders right here. Let's go here, right? So the set has four parameters: the movement speed, and the start position is a current position, I believe, left position and right position. So upper time is once it's being executed from time event manager. Basically, it will check right now the current position if it is goes smaller than left position, or and if it is go right is bigger than the right position, we will change our movement speed so that our alien grid will be moving back and forth and back and forth. And yeah, that's how basically how we add the movement for our alien grid. So that's two things we add above the Spring 4. So the next thing we need to talk about is patterns, obviously. So let's go for the first pattern. The first pattern is a singleton pattern, and I believe I need to open the UML of Sprite Game Manager right here. So the Sprite Game Manager, it has a base manager, right? And it's derived from it. And so as you can see, if we go to the Sprite Game Manager, well, the instance is held here, right? So and one so so the as you can in the game, that's how we call it the Sprite Game, right here. So that's where it's being called. So the the singleton the singleton pattern is used so that when we need to ensure that only one instance of a class is created, and it can be accessed globally. So we want to make sure basically all the managers is only being created once, right? So that's show how singleton manager works. Let's go for the next pattern. The next pattern is factory pattern. Obviously, factory pattern create you know sprite for us. So right here we create our alien factory. So the factory let's go to the create. So the factory will create the requirement aliens for us, right? So no matter it's squid, crab, octopus, or even column and alien grill, right? So next. Uh, So the factory pattern is basically used to create object of a specific class without exposing the creation logic for the clan, right? It just created for us like automatically. So the next pattern is object pool. I believe I need to open the UML of image manager right here. So object pool pattern is used when we are need to use the limit amount of number of objects that can be created into a specific number. This can be very useful when we are trying to creating a lot of nodes. So um, in the object pool, so the image manager is derived from manager base, and every time when manager base was being called, we always preload, the reserve list, and basically what it will do is it replenish our reserve node and add it to the front, and then every time we are trying to base add, which is right here, right? We'll get a node from our reserve node, and remove from front, and then we wash it, then we update the state, and we copy this node to our active list. So that's show how our object pool pattern works. So the next thing is priority queue, show in time event manager. Manager. So the priority queue pattern is used to manage a collection, of element with priority. And basically, what I did for the priority queue is that uh, I have this priority queue class, right? Um, let's see. So um, in the base manager's event manager base, it has a class use priority queue for the pure active list. I believe it's right. It should has a function called insert, right? Wait, give me a second. Oh, right. No, 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 it should go there, right? So following is the insert method of a priority queue, and it inserts the object by the order of trigger time as priority queue. And we can see the time event class is derived from the priority queue class, right? So that's how we add priorities. Uh, that's how our priority pattern works. So the next pattern is proxy pattern. It's a pretty straightforward pattern, and I should show it in Sprite Proxy. Sprite proxy, the proxy diagram. Yeah. So here's a diagram, and in the block diagram, we can see that Sprite game proxy is a proxy, right, of our Sprite game class, and it has a Sprite game object named as psprite, as we can see right here. Wait, yeah, right here. So both Sprite game proxy and the Sprite game class are derived from the Sprite base class. So the next pattern is command pattern, movement of alien grid from a repeated time command. I believe I talked about this right here before, right? So basically we have a movement command, right? The command goes here, right? So all our command is derived from the command class, and then I don't think I have a diagram here. Shit. So it doesn't matter. So we have our move command move the alien grid, and that's and every time it was being so we will add our command to our time event manager, so it will be update and execute correctly. So the next pattern is iterator pattern, draw aliens in Sprite Batch Manager. So let's go to the Sprite Batch Manager. Sprite Batch Manager, where are you? Sprite Batch. So let's go to the draw. Where is the draw method? Oh, right here. So first of all, we get our instance, then we work through our list, right, using the iterator and get a for loop, right? We create our spread batch pointers, and it will delegate the work to, the spread node manager, and we'll let it draw the spread node for us, right? So the next pattern is template pattern. It's called in spread manager calling derived class from base class. So template I don't think it's even a pattern. It's because it's pretty straightforward. And let's go to the sprite game manager. So basically, our sprite game manager class is derived from the manager base, and I guess that's being called template pattern. So the next pattern is composite pattern. I believe I talked about this before in the game section. So the next pattern is non-object. So uh, let's see, go to the composite. So in my project, all the class are derived from the composite. Use sprite game proxy, the name, the non-object right here, right? Non-object as non-object, right? Uh, and that shows we're using the non-object pattern uh, in our project. So basically, this pattern was, you know, this pattern is basically give a default behavior uh, for our project, right? So the next thing is adapter pattern, shows in texture class texture. So we have our texture class right here, and basically it has a pointer points to uh, the ASU texture class, and that is basically an adapter command pattern. I mean, so I think that's all. Let me go run for our game, right? I use G pattern right here in the update section, right? So G is I hit once I hit G, the the sprite box will be disappear, should be disappear. So and that's how it looks like. And yeah, thank you.